Alrighty, thank you for your efforts. So I hope you find it interesting, and it's definitely important. I can say that. And now we'll be looking at problems where you're given a line angle formula and asked to determine the number of carbons in it. Hopefully, I think you can do that well based on the earlier answers I've received. And given a line angle formula, determine the number of hydrogen atoms which have been omitted, but they were there all the time. So we're kind of working in reverse. We're given this at the bottom, and we're asked things about it. What did it used to be? And we're kind of working in reverse, and that's important itself. Okay, so remember the types of carbon atoms are endpoints, vertexes, and junctions. We don't see a lot of junction carbons, do we? Nope, they're just for triple bonds. Let's see if we can wipe out a few of these all at once. So I guess it's on page 11, if I had to say. Yeah, 11. It's kind of overwritten by the worksheet itself, but page 11. Sinclair, would you like to give us A, B, C, and D? How many carbons overall? Oh, that'll suffice for us. Thank you. Correct. Thank you. 6 carbons. You heard it. The endpoint, an endpoint, and the rest are vertexes. Keep going, Sinclair. You do A, B, C, and D for us. Okay. I seem to remember that answer, but I should check it. Yep, correct. 9. Thank you. And for C, 9 again, huh? Yep. Yes, indeed. 9 again. Thank you. 9, you heard it. Any questions that match what you had? Good. And the last one, which can be tricky. Sorry to talk over either. 3, correct. 3 carbons, not 4 or anything else, but 3. Okay, thank you. Very good. So it went 6, 9, 9, 3. And the next one, Victoria, can you do these? I saw you working on them.
For E is 8.
E is 8, huh? Okay, you are correct. We have two endpoints. We have 2 junctions, JJ. And then the rest are vertexes. 8, you said. And here's the next one.
5.
Correct. Thank you. 5. And the next one.
Also 5.
Yeah, looks like it's more, doesn't it? But it's 5. And the last one here, I had to make a special note for you and for everybody. This is like not so much the overhead blimp view, but when you're walking into the stadium, Lincoln Financial Field with ticket in hand. Okay, so this is this perspective, edge on. Did I write that there? No, I should write that there. Go ahead, Victoria, if you would like.
There's 7.
Okay, you're correct. Yep. Thank you. Edge on. So if you ever see that again, I don't know if you will or not, but that's the story with it. I will. Or looks like carbon 7. Carbon 7 is suffering from a nosebleed. It's way up there, high in altitude. This is edge on, and you can kind of get the idea. But we'll do some more. Yeah, very useful. Okay, can I have Jordan?
3.
3, thank you. It's a very quick answer. Quick to the draw. And the next one?
5.
5, good. Yep, it's an endpoint. It just happens to be part of a hash.
4.
4. It's funny this carbon hydrogen bond showing up, but sometimes they will show them for one reason or another. So they must have chosen to show that on purpose. Chapter 5 will show you why. And 4, correct. Will be chapter 5 why they chose to show that hydrogen. Called a chiral carbon. And 4. Thank you, Jordan, and everybody, Tori, Sinclair. Any questions about your classmates' answers? All righty. And time to move on. We'll skip these, unfortunately. We'll be here till dinner. So, and now you'll report the number of hydrogen atoms at the pegged carbon atom. Okay. There's a formula for that and a itinerary. Your possible answers here, everybody, are it could be 0 hydrogens, 1 hydrogen, 2 hydrogen, or 3 hydrogen atoms. 0, 1, 2, or 3. That's your possible answers. 0, 1, 2, or 3. So you'll see me do a few of these to start out with. We're doing in reverse. How many hydrogens are at this peg chip? They're not shown because of the brand of notation, but they're there. They're there all the time. How many hydrogens are at this location? You know. 3. Correct. Wow. I didn't even cover it. 3. Correct. Thank you, Julian. Wow. Oh, I'll come back to you. Maybe you can help me do a few more. Okay. Thank you. How I would solve this is you can see an itinerary here. Put your pencil on the paper at the chip. Pencil at the chip. Pencil touches paper at the chip. And just trace rays. Or like a ray in a geometry class. A ray is an arrow. So pencil at the chip, trace a ray. I have 1 ray. So 4 minus 1 tracing is equal to the 3 you heard from Julian. 4 minus 1 is equal to 3. You'll have a homework about this. You'd like to go ahead, Julian? You can do. Thank you.
B.
Yeah, do B.
B 0.
Correct. 0. Correct. Thank you. If we were to have a hydrogen here, don't you agree it would disobey the octet rule, right? Yeah, 5 bonds at a carbon. So if you put your pencil at the chip, pencil touches paper at the chip. Can you hear the pencil touch the paper with your ears? Then you trace 1 ray, 2 ray. Trace the bonds from the chip emanating outward. 3 rays and 4 rays. 4 minus 4. You may have a question. Do I have to show the calculation? No. That's nice for folks who don't need it, but 0. I just wrote the 0 like that. Otherwise, it looks like an oxygen atom. So 0, a digit. And you may have a question. Do I have to show the rays? The answer is no. You don't have to show the rays. Just the number will suffice, actually. Want to try again, Julian? Yep.
Would it be 1?
Correct. Thank you. The person in the first class said their answer and they had to correct themselves, as my memory serves. So you got it right on the first try. At least they corrected themselves, right? So 4 minus 3 is equal to 1. 1 hydrogen. I could draw it out if I wanted to. I could draw it out. Good. It was there the whole time. What's in store for us now? Okay, Julian, you're up again.
2.
Correct. Well done. Yep. So a wide array of possibilities just from A, B, C, and D. So a lot of different type of outcomes. There's 1 ray, there's 2 rays. A double bond, trace both bonds of the double bond. 4 minus 2 equal to 2. Well done. Wow. Pro. And 1. You can state the formula one or two ways, even more ways. I just typed it up like that. So why 4? Because carbon makes 4 bonds. Any questions? Okay. Would you like to try some, Molly? Let's do E, F, G, and H. No pressure. You've never seen this before, right? So this is not like this is review from general chemistry. So how could it be? Okay. We're doing pencil down at the chip. So far, so good. Okay, thanks for following along. So I'm going to trace 1. Are you with me so far? Okay, thanks. And then there's a triple bond to our left. 2 tracings, 3 tracings. That's a hard one. Yeah, this is the first class example but did you follow the gist of it? Okay, thanks. 4 minus, if you wanted to have this notation, 3 to the left and minus 1 to the right, 0 hydrogens there. And try this one, Molly, for F if you like. Mm-hmm. Yep, pencil it on at the chip, right? Okay. And you're correct. It's either 1 or 2. Yep, good. So we have this tracing. And we have, this is a fluorine bond, I know, but it's still a bond. Now what you're thinking is it carbon-carbon bonds only. That'll come into play for another, it's called, Molly, it's called degree of carbon, 1 degree, 2 degree. I've not talked about that yet, but 4 minus 2 is equal to 2. Try again, Molly. Thank you. These are all yours. Take your time.
4 minus 1 is 3.
Correct. Yep, good. 3. That's our first type of problem we've seen of that, huh? Endpoint carbon you just investigated for us. And that's 1 ray. 4 minus 1 is equal to 3. This is very important stuff we're doing now. And the last one? 2, correct. Pencil down at the chip, trace. There's 1 tracing and another tracing. So we're seeing what can happen. Maybe you can have a heteroatom like a fluorine, or maybe you can have it at the end point. So there's a lot of different permutations of this. So 4 minus 2 is equal to 2. Interesting, isn't it? Thanks a lot. Very good. And do I have permission to go ahead? All righty, thanks. We'll see what's next. Would anyone like to try some of these? I never used to like when teachers used to pick on students. Thank you, Shelby.
1.
1, correct. Yep, I can draw it at vertex rule, right? The vertex points up, the hydrogen points up. So good. So I draw a horizontal. Do I have to draw in the hydrogen? Nope, happily not. 4 minus 3 is 1. How about this one, Shelby?
1.
1, correct. It doesn't matter that it's a hash bond. It matters that it's a bond. So carbon can only make 4 bonds. 1's used up, arrow. 2's used up, arrow. 3's used up. 1 is not accounted for. It's part of a hydrogen. So 1 hydrogen there. And do you know something? That hydrogen is hooked up as a wedge. I'm going to make that wedge taller than the hash because it's closer to us. Oh, that's a. Do I need to draw it in? No, not quite yet. We're not there yet. Keep going, Shelby.
3.
1 here. 3, correct. That reminds me of the example we did with your classmate, Molly. Endpoint. And the last one?
1.
That was a tricky one. Good. 1, correct. Pencil down at the chip, trace each bond. I got 1 ray tracing, 2 ray tracing, 3 ray tracing. 4 minus 3 is equal to 1. Okay, so those are some problems which are very important. Any more requests for doing these? See if there are interesting ones that fly ahead. I don't think so. I think we've seen everything. I see some interesting ones I wanted to highlight, so I guess we'll do the highlighted ones. We'll do some highlighted ones. Heather, would you like to try Y? Thank you.
2.
2, correct. And Z, Heather?
2.
No. Geez, there's a lot of things going on in it. I'll say that for it.
Oh, wait. 1.
Less than that even, 0. Because the carbon's making 4 bonds already, huh? Yeah, that was a tricky one. Yeah, that was a tough opponent, so we could say. Yep. When baseball teams play other the team's going to be easy or hard, you know. That was a hard opponent. The 0 though, because this carbon's already making 4 bonds, isn't it? So yeah, okay. Okay, let's see what else is up.
3.
We'll do AB now. Okay. Yep. So 3 is the number of rays. I agree with you. So.
I was doing one before that.
Oh, were you? Oh, okay. Thank you. You are correct. Yeah, good. That counts in regulation. Yeah, that's a regulation win. And 4 minus 3 is equal to 1. 1. Okay. Here's a team with a simple game plan. AE. Let's see if they can confuse anyone. Let's see what they'll try to confuse you. Would anyone have an answer to that one? AE. Yes, Shelby. 1, correct. Thank you. That's that. Yeah, and here's 1. That's kind of like the other example. So I think we've seen a representative number of these. I'm just drawing this in as a wedge. So you know what to do when it comes to that. Yes.
Is AH2?
Yes. AH is 2. Yep. There's the chip. Trace. Yeah. 4 minus the 2 is the 2. Mhm. On the next page, a little bit more, but different eventuality. Any questions before I would go ahead? Okay, we'll see what's next in store. So all this is saying to you, to boil it down, is that if you're investigating a carbon, be it an endpoint or a vertex or a junction, whatever it is, and this carbon has a charge, positive or negative, you have to change the formula. It's not 4 minus the number of bonds made, but 3. That's all. You'll have a homework about this. I think that'll be due on Tuesday, this homework, this type of homework. So as you can see, these problems don't take too long. And as I said, you don't have to provide the calculation. So here we're going to use 4 minus a quantity because that's carbon's neutral, right? 4 minus a quantity. But if you're investigating a carbon which is charged, positive or negative, it's 3 minus the quantity. Because a carbon which has a charge, such as a positive charge, is only making 3 bonds, not 4. That's why the 3. It says it up above. Much more better than what I stated it. So let's see if we can ask a classmate to come up with these answers. Would you like to try, Michael? Thank you. I think it's going to be 3. Yeah.
I skipped to the.
Oh, yeah. All right.
Yeah.
All right. Yeah, you're right for the other ones. It's going to be the same answer. Do you know something? It's going to be the same. So it turns out you had a winning record after all. So good. And this one was 4 minus 1 is equal to 3. Good. Okay. So I just want to do one of those because I only did. So let's see how you do with that on the homework for Tuesday. The molecules change, but the rules remain the same. Yep. It'll be interesting to see what you come up with. And if I didn't assign homework on this, I don't think I'd be doing my job as my instructor. I don't think I would be earning my pay. If I didn't give homework on this, it's, oh, you know, okay. So, I don't think I'd be earning my keep. So, I have to assign homework, sorry. That way you get some feedback and you can put pencil to paper and learn it some more. As much as I like to do more examples, I have to cover some more. So we're not going to do this. As I said, we can't do everything. And now on page 20, I'd like to give you a shortcut. To solve these. Zoom in real good here. Good, I'm screen sharing, I'm recording. I'm 20. Providing there are only single bonds for carbon atoms in single bonds, the shortcuts are, oh no. Oh, where am I? Okay. Endpoint, each and every time, it'll work out to be 3 hydrogens. An unbranched vertex, no branches. Each and every time, it'll work out to be 2 hydrogens. You can run the formula if you want to. 4 minus the number of bonds made each and every time. There is a vertex with no branches. That's going to be 2 hydrogens. Save myself some time. I know why that is. I can prove it to someone if they dare me. The vertex, no branches, 2 hydrogens. Here's a vertex with a branch. This could either have on it, it depends, 0 or 1 hydrogen. Carbon can only make four bonds. So if you have 2 branches, you can't have 2 hydrogens. We have 6 bonds to carbon. What do you want? You want branches or hydrogens? So you have to, you can only have, you have a cap of 4. So this has 1 branch downward, right? Branch is down. I circled it. So therefore, this carbon has, you can calculate it. You have the power to calculate it, 1 hydrogen. Where a line ends, E, there's nothing after it, it's just empty space. 3 hydrogens. Where a line ends, the end, nothing beyond this, 3 hydrogens. Endpoint, beginning and end, 3 hydrogens. Vertex on branch, 2 hydrogens. If you have a branch, it could be 1 hydrogen or 0 hydrogens. Helpful hints, quick tips. I can come into this one and say, endpoint, 3 hydrogens. Unbranched, 2 hydrogens. Branch, I gotta look at that. Line ends, 3 hydrogens. Unbranched, 2 hydrogens. Unbranched, 2 hydrogens. Line ends, 3 hydrogens. As quick as that. Go back and calculate this. I have 1 branch. I have 1 hydrogen. A branch plus a hydrogen plus to the left plus to the right. 1, 2, 3, 4. Carbon makes 4 bonds. Something to ask? Here's an example of a molecule which has 2 branches. Three hydrogens, 3 type 2 hydrogens. Whoops. Unbranched vertex, 2 hydrogens. This one has 2 branches. Kind of made up its mind. I favor branches. No more room for hydrogens. The suitcase is full. There's 0 hydrogens. Carbon can only make 4 bonds. It already has 4 bonds. If you take a look at that upward vertex, line ends, 3 hydrogens. Okay. Okay, good. Now let's see about the next worksheet. We'll apply that. 2 worksheets to go. I just skipped one or skipped over one. Good job, everyone. Now we're up to see you're given a line angle formula, and can you come up with its full so here's a nice example. Nice enough example. You're given this, can you determine that that's C sub 8 H sub 16 O? So that's the task now. Of the two remaining tasks, this is probably the hardest. Yeah, I'd say. Where X is a halogen atom. In other words, fluorine, F, chlorine, Cl, bromine, Br, or iodine, I. Where X is a halogen. Well, I'll start us out here. How many carbons? We've done that problem, haven't we? We took a hack at that, right? So we did that by itself. So that shouldn't cause you any pause. On the auction, that shouldn't cause you any pause. For how many bromines, that shouldn't cause you any pause. The only thing you really have to concern yourself with is the number of hydrogens. So you can do the shortcut or count them out in full. So let's see what we get as class responses here. And in the meantime, I'll type these out. I hope I'm doing a clear enough job showing you the strategies, and we'll do some examples here. I can't do subscripts on this without a lot of trouble, so not like wasting 20 seconds per subscript. So it's not too exciting to watch that, so I'm just gonna some interesting ones. Oh, I like D. I just talked about that when you have a carbon with two branches, huh? That's how chemists name things universally. C first, then H, then N, then O, then X. Always been like that. Okay, and the good thing is you get partial credit. That's good, huh? So if you get the number of hydrogens wrong, at least you get some partial credit. So let's see if you can come up with an answer here. The number of carbons and all, the number of hydrogens. How will that turn out? Yeah, we're kind of right where I took just over 2 hours. So kind of, I expect we'll end probably at 2:35. Julie, do you have an answer already for this? Would it help me?
Yeah.
All right, thank you. Let's see. We're looking at A. Zoom it in here for you.
Somebody's telling you how many atoms there are?
Yeah, how many carbons?
3.
Correct. It's one oxygen, one bromine. Thanks a lot, you know. Like, yeah. How many hydrogens? Tricky in different ways. No pressure, therefore. Wow, excellent. Well done. Congratulations. 7. So there's a lot of things going on there. So 2 H's here. There's a vertex unbranched. This is a vertex which has one branch, right? One branch up, bromine. 1 H. And where a line ends, 3 H's. And you even remembered to add this H in there. Wow. That is some awareness, because I did not talk about that, did I? Not at all. I didn't even bring that up. Add all these up, and that's the 7. Very impressive. Wow. If you Joel, you may want to do the homework tonight before you. Yeah. Yeah. You're on a winning streak. So C3H701. Well, that. Yeah. Of course, the first one from the first class did not get that right. So let's see the next one. That had a lot of things going on there. Okay. Mitab, you wanna, did I say your name right? Mitab, okay, thank you. I'll get the hang of it sooner or later, else you can help me. How about the number of carbons? 8, I agree. Thank you. Auctions 1, thanks a lot. How many hydrogens? This is, I don't say I blame you for not knowing that, but thanks for the carbons. And did you want to say something now, or do you want me to? Wow, I think you're right. Wow, wonderful. Oh my goodness. Jeez. Whoa. Now these are, I'm going to put question marks near these. All of our shortcuts kind of fall apart. I have to guard against going too fast because I was given the right answer, so I have to guard against going too fast. All these question marks are our quick methods fall apart. We have to solve this, but you know something? Because these are similar, they're in a ring and they have a double bond. Whatever the answer is to one, the answer is to each one of them. Do you follow? They're all part of a ring. Check. They all have a double bond at the vertex. Right. So if I get one of them, I get them all. And I'm going to put a different symbol there, asterisk. I have to solve that. The only thing maybe I have going for me is that where a line ends is 3. And then, excuse me, then I have to think about this, where the ampersands are. So looks like you had to root through a lot of stuff there to churn out that 8. The ampersands, that symbol is 0 hydrogens. There were no hydrogens there. The question mark, well, this is cool, isn't it? ... 1 hydrogen. If you do the 4 minus the number of bonds, and the asterisk is ... 1 hydrogen, and that was the 8. Partial credit afforded, and practice will help. Practice will help. A lot of components going on there. You can solve them one by one if you want with the Ray technique, you know, so you don't have to use a shortcut. So if you want to just go through one by one and do the Rays, 4 minus the number of bonds made, that's another way to do it. Here's an interesting problem. Thank you, Meetob. Good. Here's an interesting problem. Let's see if we can, if someone has gotten as far as this. Victoria, did you get this one? C? Okay.
It's maybe C4.
Yeah, correct. That's hard kind of by itself, isn't it? 4. Mhm.
H4.
Correct. Wow, my goodness. We'll have to enter you guys in the contest. So C4H4. The 2 question marks there. Our assumptions fall apart, you see. So we had to work that out. Each of those has 1 hydrogen. Mhm. Don't forget the hydrogens like you had with Julian, where they were already there. So add those in there. 2 from the question marks, one apiece for each question mark, and add the 2 that are already there on heteroatoms. Whoops, what, 4, and how many auctions even?
Also 4.
Wow, correct. And I'm gonna ask a good answer. Oh yeah, this one. We'll do D, E, and F, just so that I treat your section the same as the other section. We can do this shortcut. Hooray! I'll help us here. Remember the shortcut. Why can I use a shortcut? Because there are no double bonds, and you know I have clearance to use a shortcut. turn on the typewriter. Endpoint 3, unbranched 2. A branch. Got to think about this. Unbranched 2 hydrogens there. Where a line ends 3, where a line ends 3. I got to think about this B. Gonna turn it into a number. What number are I going to turn it into? How many hydrogens there? Correct. Thank you, Jordan. 0. It's one of those things which have two branches and 0 hydrogens. Because if it had 2 branches and 2 hydrogens, then you'd have a carbon with six bonds. That's way too high. Two bonds and 0 hydrogens, and whatever this would turn into. 7 and 15. I remember that from the last class, C7H15. Just see if you have anything to ask. Okay, and the next one, it goes something like C, H, N, O. Yes, Jordan, thank you.
C2,
Correct. Thank you. Good.
and then H5.
Wow. Excellent. 1 here, 3 here, 1 given, 5. That's the 5. Excellent. You guys have very analytical minds. C2H5NO. Okay. And let me just circle that just to be sure. And here's this one. And our last example. Let's see if maybe someone, but thank you, Jordan. Yeah. Let's see if someone else would like to cover this. Okay, you want to do it? Okay.
C12.
This one confused me last time. 5. Can I get a second for 12? I think I just can't count this. So thank you. 12. Thank you, Sinclair. C12. Did you figure out the H's where the H's were? And I think you're right about that. So I can count the H's better than that one. I think it's gonna be 8. Yeah. Let's see. Where did you find the? Have you found it?
Yeah.
Okay. Yeah. So there's output X's here. And N2. Thanks for the volunteerism there, Sinclair. So yeah, those X's work well. So good notation on my part. All right, so that's our last example with this. And I promise you one more worksheet. It's at the very end. Anyone need a moment longer? All right, then we're going to go ahead. At the very end, it's called degree of carbon. So we'll only do, I only think we'll need to do like eight examples, of which I'll do the first 4. I can boil this down for you. It's on page 27. You'll have a homework about this, I believe. And I'll give you the homeworks in a moment's time. So we're going to classify carbon atoms based on 1 degree, 2 degree, 3 degree, or 4 degree. And this is where Molly was maybe deciding, do I count the carbon-fluorine bond or not? So in this type, as I said, Molly, as I said, that what you were doing will become pertinent. This is where it becomes pertinent. You're only counting, in particular, 1 carbon-carbon bond is a primary. A 2 degree carbon is, to just boil this down, is any peg with 2 carbon-carbon bonds. 1 degree and 2 degree carbons react in a round bottom flask similarly. 3 degree carbon is any peg chip, any point with 3, in particular, carbon-carbon bonds, and likewise for 4. So So we're only counting carbon-carbon bonds, just like driving to the store wherever you shop for food and going in there with a one-track mind saying, I'm getting Jif peanut butter. And if they don't have Jif, I'm just going home. So the Jif's all out. They have they have Peter Pan peanut butter. You don't want that. You want Jif peanut butter. You're out of Jif peanut butter. I'm going home. So I want only carbon-carbon bonds, nothing else. That's all I'm looking at. One-track mind, carbon-carbon bonds. Any questions? Okay. So this is a pencil down at the chip and trace the number of carbon-carbon bonds. I should have typed that out, sorry. Trace the number of carbon-carbon bonds. Oh, I guess I'm not active enough. You're tracing carbon, in particular, carbon-carbon bonds. While I walk around the room, can I get a student to give B, C, and D? Heather, can you do that?
You want me to-
Yeah, thank you. Is a highlighted carbon for molecule B, is that a primary carbon, a secondary carbon, a tertiary carbon, or a quaternary carbon? You see those words there, methyl, methylene, methine? You don't need to know them yet. Methylene, correct, 2 degree. 2 degree will suffice. For B, it's actually 3 degree. I beg your pardon. Methine. Trace carbon-carbon bond. Trace, pencil down at the chip. You've done this before in a different way, but trace. 3 carbon-carbon bonds. Do you follow? You have this? Okay. 3 carbon-carbon bonds through tertiary. Would you like to try this one, Nicole?
Which one?
C, please.
Is it 4?
Correct. That's a quaternary carbon. Correct. Well done. Anyone like to try D, Nicole? Oh, sorry, Heather. I'll come back to you. 1, correct. Primary. Yes, thank you. Okay. Any questions about how we got that? Okay, you'll have a homework about that. And let's do E, F, G, and H, and then you'll be set up. I think that'll be ample examples for that. Heather, would you like to try E? Yep.
3.
I'd say it's 2 because we're only counting carbon-carbon bonds. See, you had you had the surprise, and I was thinking about warning you, but I didn't. So sorry, I was kind of wondering what do I do? Well, and then I said, well, I'm not going to warn, so we'll see. But low risk. This is the first time you've seen it. 2 degree carbon. You want to try the next one? 3, correct. And let's see if we can get, yeah. Wow, correct. Good answer. Yep, it looks like it's more, doesn't it? It's 1 degree. 3 degree, 1 degree. And is H 2 degree? Can I sell you on that? No. Nope. No sale. 1 degree. I thought you would have gone for that. Good. 1 degree. Here's our revised syllabus schedule. You can wear shorts next week. I have a change of schedule. We're doing molecular modeling. Nothing is due next week. Cool.
Starting on the quiz.
I would like to have the quiz before that information gets too stale. But
And what about
I'm sorry?
What about the type report?
That's pushed back a week.
Okay.
You anticipate very well.
Yeah.
Very good.
Wait, do we have to do that?
Yeah, you have a quiz about recrystallization.
Okay.
A lot of quizzes about recrystallization. But you can wear shorts next week. I think soon this will be you're working with your partner and you're making molecular models. These 2 homework assignments are due on Friday, and they'll be in lecture. The assignment I'm passing back now is Friday for lecture. You can do it with a partner or partners. Friday, you're welcome. It may look familiar. Friday for lecture. You're welcome. This counts for lecture homework. In other words. Counts for lecture homework. Thank you guys for your participation today. Easier.
And is this due Friday?
Yes, Friday, please. Yep. That's homework 1. This next homework I'll pass back, I'm going to give you 4 homeworks. The next homework is also due Friday. This one will probably take you less time. All I need is the number 0, 1, 2, or 3. Friday, you're welcome. Friday for lecture points. You're welcome. Sorry, I couldn't write it on there myself, but you know, when I printed this out this morning, I was going to print you one bundle, and then I said, oh, no. I had to split it up. And then it dawned on me when I was passing back the work, oh, this puts me something on Friday, someone on Tuesday. This is due on Tuesday. This is for lab points here. This is due on Tuesday. Tuesdays for lab points. You can do this with, you're welcome, with your laboratory partner. You can do this with your friend in lecture, either section. You can do this for Tuesday. You're welcome. So it's similar enough, when you'll have 2 different days to handle this very important topic of the number of hydrogens adding carbon. Tuesday, if you will. And one last homework, also due on Tuesday. I don't need your homework. I'm not doing my job. I'm freeloading if I don't give you homework. I'm a freeloader. If I don't give you homework. And of course, so here's your homework for Tuesday. You're welcome. Give you some time with these more difficult problems. If I do, you're welcome, one with a group member, that means I can do the other as an individual, but I don't have to do them all with a group member. I can handle it. I've been enough secretarial skills, I can handle it. Let's do Tuesday. Okay, thank you all very much. You did very well. I'm very happy that you know more about line angle formula. You have the power now. Next time.
They're just like. Yeah.
Should record this.